This webcast abstract provides an overview of a full webcast menu, which examines a mathematics lesson taught within a three-part lesson framework. Viewers will see how the student's prior knowledge is activated. They will observe students engaged in completing the lesson problem, which is designed to move the students forward in their learning trajectory from wherever they are in their understanding. Viewers will also notice how the teacher facilitates students sharing, then captures some of the key learnings and follows up by creating opportunities for practice. Throughout, the teacher assesses, prompts, allows for differentiation in how students learn, and extends their thinking.
Let's start with our question for today.
Hamza loves dark chocolate with orange bits and black.
The teacher chooses to begin with a mini problem that is designed to activate prior knowledge from earlier lessons. Students work collaboratively and in small groups to solve the lesson problem. They think about their strategies and look for the most efficient way to proceed. The teacher assesses for learning and selectively chooses times to provide immediate feedback.
All right, so we're going to move on to the task that you're going to be doing in your laptop groups today. Can I get a student to read the question out to me, please?
A turkey weighs 9.75 kilograms. It takes about 20 minutes to cook 500 grams of this turkey. Okay, so we should, from going from kilograms to grams, we should multiply by 1,000.
So 8 is multiplying by 1,000, right?
Yeah.
Okay.
So can you multiply by 1,000?
So what we know is that 20 minutes equals to 500 grams, right?
Mm-hmm.
So if we take 500 grams divided by 20 minutes, then that will equal 25 grams.
For 1 minute.
25 grams for 1 minute. And then we converted 9.75 kilograms to
9,750 grams. Can you guys think of any other one?
Maybe we could have instead of doing 80, 160, 320, we could have added them both up, all three of them. We could have just make it faster. We could have added all three of them, and then just put it together and then put the rest.
I like this rate thing that we did because it makes it look more clear.
Yeah, rate is, and people could understand it better.
Yeah.
It seems like most of you have gone to what you think is the correct answer. Now you need to explain and share your thinking. When you're sharing your thinking, make sure that you look at the success criteria for sharing your thinking, that you meet each of those criteria. And then
While the students work on the lesson problem, the teacher assesses their learning, facilitates discussions among students, primarily through questioning, and also observes different student solutions in anticipation of the third and final part of the lesson. In the math community, a gallery walk builds communication skills, collaborative skills, flexible thinking, and being open to other people's point of view. It extends students' content knowledge as they struggle to understand and provide feedback to their peers. It actively engages students in their own learning and begins to support consolidation of the mathematics.
They did 20 minutes.
Yeah, they did ratios.
Yeah, they did ratios plus 10 minutes again and again and again.
As well as they put they did something. They put mass in kilograms as well.
Yeah.
So let's actually talk about this. Do you guys actually really understand the calculations? What they're trying to do?
Overall, that was very good.
Yeah.
Students are given the opportunity to consider the feedback they've received. After reflection, they make decisions to use some, all, or none of the feedback they received, and through discussion, they justify the decisions that they are making. During the first part of the Consolidate, the teacher facilitates students with student conversation and occasionally asks probing questions. She continually checks for understanding and acts on the assessment for learning data. In this Consolidate, 3 groups are selected to share their work. The order of the presentations is designed to scaffold the construction of understandings by the entire class. The first group uses a semi-concrete representation of the turkeys by selecting a virtual manipulative to help them organize their thinking. The second group has a similar solution, using a double number line to organize their thinking, while the third group uses a mixture of unit rate and rate table. As each group presents, the teacher will draw attention to the mathematics in the solutions and will ask students to make connections between the 3 solutions.
So you've seen several presentations. Now I want you to turn to partner think first, then pair share. What were the key ideas or strategies from the 3 presentations, okay? So can you do that right now, please?
For Caitlin's group, they use the rate table.
To move further towards consolidation of the learning, The teacher first highlights and summarizes the key mathematical concepts, algorithms, and/or strategies related to the lesson learning goals. These will be referred to in later lessons and will help form the success criteria related to the learning goals for this unit of learning. She will then assign independent practice. Students work individually or in pairs to practice and apply the tools, strategies, and concepts from the lesson. Practice problems are designed to be similar in structure to the lesson problem, allowing an opportunity for students to consolidate their learnings.